one color. This is a one. This is a two. This is a three. This is a four. This is a five. One, two, three, four, five, six. So we have the colors. That is a VIB GR. GR. One, two, three, four, five, six, seven colors we are getting. One, two, three, four, five, six. So we are getting one more color. That is this is color. This is a colors. We are saying this is a colors. This is a colors we are saying. Colors we are saying. Colors. We are saying this is a colors. This is a colors we are saying. So you take the white, you take a screen. The screen screen keeps here, so keeps here. This light rays. This is a ray pulsing here. We are getting the colors. We are seeing to the colors. This is a color. This is a indicates. This is a violet. This is indicates violet. This is indigo. This is blue. This is a green. This is yellow. This is orange. This is a red. We are getting the colors. We are getting the colors. This is the colors we are seeing. This is a rainbow colors we are seeing. Here are deviation of red. Deviation of red. Deviation of red. So this is the last one. This light. Dispersion of light. So white light falls on PQ surface of the prism. This white light split into seven colors. Seven colors. So that is again that it travels from denser medium to greater medium. Again, it's bending away from the normal. So we are giving you seven colors. Seven colors. We are not seeing to the seven colors. So we take the one screen. The screen keeps this side. So some colors falls on the screen. So we are finding the colors on the screen. Colors on the screen. The colors is VGR. So V means V indicates violet. I means indigo. B means blue. G means green. Y means yellow. O means orange. R means red colors we are seeing. Red colors we are seeing. So you see that what is deviation? So what is the meaning of angle of deviation? Angle between this is a ray. This is the actual direction of incident ray. This is a incident ray. This all lines we are calling refracted ray. We calling emergent rays. This is emerging rays. These rays are emerging from this surface. From this surface, this is one ray indicates emergent ray. All rays are emerging from this surface. Okay, angle between this incident ray, this is emergent ray. Angle between incident ray, emergent ray, we are calling angle of deviation. Angle of deviation we are calling. So angle of deviation we are calling. Okay. So what is the angle of deviation? For red, this is a white. Deviation of violet, this is a greater than 2. Deviation of the red. Deviation of the red, this is a deviation. And red colors, red. Red color having wavelength is some more wavelength. And so wavelength of the red so greater than 2 wavelength of the violet. So red having wavelength is 6,900 angstrom, and violet having violet having wavelength is 2,500 very nearly 2,500 angstrom. So that is wavelength of wavelength of the colors. Wavelength of this color. So this is a deviation. Okay. So this is a dispersion of light. Dispersion of light. Okay. Next concept. Next concept. Rainbow. So you are seeing to the next one is rainbow. Now I'm going to explain. Right. So next, I'm going to explain rainbow. Rainbow. This is very very important. So rainbow. So this is a rainbow. So we have the rainbow. So here, the first one is keyword. So first dispersion, dispersion of the light, dispersion of light. So next to refraction of light, refraction, refraction. Third one is total internal reflection. So this is a dispersion, refraction, total internal reflection. So we have the primary rainbow, primary rainbow, primary rainbow. Second one is secondary rainbow, secondary rainbow, right? This is a secondary rainbow. Okay. Dispersion of light, refraction, total internal reflection. So primary rainbow, secondary rainbow, secondary so rainbow. So first of all, dispersion of light. So what is the meaning of the dispersion of light? Dispersion of light means so dispersion means white light falls on the speaker surface of the prism. That white light splits into seven colors. This colors dispersion of light. So refraction means what is a refraction? Light ray which deviates or bending from its actual path on entering into the second medium is called as refraction. Refraction. So what is the total internal reflection? Already I explained to you total internal reflection. So first of all, total internal reflection. What is a total internal reflection? Total internal reflection means we know very well. T means total, I means internal, R means reflection. Total internal reflection. So here we have the three conditions. Condition number one, light should travel from, light light ray should travel from. So condition number one in total internal reflection. Total internal reflection. So what is your condition number one? So light should travel, light ray should travel, should travel, 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 light ray should travel travels from denser medium to, denser medium to, medium to, where are denser medium to, rare. So light ray should travels from denser medium to rarer medium. Second point, we have the conditions. What is the conditions? Angle of phi greater than 2 angle of R. So refractor railway. Second situation, angle of phi is equal to critical angle. Angle of phi is greater than 2 critical angle. This is a three situations, three cases. Case number one, this is a case number one. This is a lower part is taken as a denser medium, upper part is taken as a radar. So light travels from denser medium to radar. This is the actual direction of ray, but the light travels from denser medium to radar medium. Refractor ray bend away from the normal, This is instant ray. This is angle of I. This is a refractor ray. This is angle of R. In this case, deviation is equal to angle of phi greater than what is the situation in this situation? Light travels from denser medium to radar medium. This is angle of R greater than angle of I. So this is a situation. Okay. Second situation in the instant ray. Angle of instant ray goes on increases. This is a angle of instant ray. Next ray, angle of instant ray goes on increase. So what will happen in this situation? Refractor rays travel along the interface line. This is a normal line. This is the angle between here. This or angle of R is equal to 90 degrees. 90 degrees. Refractor ray travels along the interface line. So next the third situation. So this is because this is an angle of phi that is equal to critical angle. This is the angle of incident ray is equal to critical angle. Critical angle. So next ray, coming ray, next I'm taking angle of incidence. Angle of incident ray is goes on increases. Angle of incidence is greater than 2 critical angle, greater than 2 critical angle. So this is angle of phi. It is greater than 2 critical angle. This is a angle of phi is equal to angle of phi. This is a angle of incidence. This is equal to critical angle. And next, I'm taking angle of incidence is greater than 2 critical angle. I'm taking this is angle of phi. Angle of phi. It is reflected to the same medium. So we call this is this place. This is a ray takes a total internal reflection. This is angle of phi greater than critical angle. Critical angle. This is a total internal reflection. Total internal reflection. Already I explained to you this concept. Okay. This is a total internal. First case. This is a middle case. This is a boundary. So before this one means refractor in the radar medium. After this case, reflection ray. This is a we call reflection ray. Reflection ray in a denser medium. Light travel from light is a travel in the denser medium. Strikes at this point. Again, it is reflected to the same medium. Again, this is a ray coming from point of incident. This is ray is reflected to the same medium from point of incident. So this is a critical angle. Angle of incident is equal to critical angle. So in this situation, so you see this situation. Before this situation, what is the meaning of this situation? Angle of phi less than angle of r. In this situation, refractor in a radar medium. In this situation, refractor along the interface. In this situation, angle of phi greater than angle of c. Reflection ray is a denser medium. This is a reflection ray denser medium. But this is a radar medium. This is a denser medium. Both lines are we call this is interface line. Interface line. The refractor in interface line. Refractor interface line. So this is what we call this is we are calling this is one refractor in a radar medium. Refractor in a along the interface line. Reflection ray in a denser medium. This is a below situation. Ray is in a denser medium. After this situation, reflection ray in a denser medium. At this place, after this case, all rays are traveling from denser medium to again that is reflected into the same medium from the point of incident. Which called as at this situation take the internal reflection. At this situation, angle of incident is greater than 2 critical angle. At this situation takes a total internal reflection. Total internal reflection. That is the case of total internal reflection. Okay, this is what we call total internal reflection. Total internal reflection. So you see that I'm going to explain the primary rainbow, secondary rainbow. Primary rainbow, secondary rainbow. This is all key points. Key points. Okay. So next, I'm going to explain the natural rainbow. Natural rainbow. Formation of natural. Natural rainbow. You're seeing to the natural rainbow. So I'm going to explain primary rainbow, secondary rainbow. Primary rainbow, secondary rainbow. Primary rainbow, secondary rainbow. Rainbow. Good enough. So primary rainbow, secondary. Primary rainbow, secondary rainbow. Primary rainbow, secondary rainbow, right? Okay, this is a rainbow, but this rainbow, actually, what is the shape of the rainbow means? This is a spectral shape, but you are not seeing to the spectral shape. Suppose you are in the earth, so you are able to see the shape of the rainbow is semicircle, semicircle. So this is center of the point, center of the point, and observe rays at this point. Observe rays at this point. Observe rays at this point. So here, this observer from here to here. This is okay. You see this is a semicircles. You are seeing semicircles. Okay, semicircle. This is a rainbow. But you are in the ground. You are seeing dispersion of the rainbow. You are seeing dispersion of the rainbow. Rainbow. You are seeing dispersion of the rainbow. You are not seeing to the full portion of the rainbow. Full portion of the rainbow. You are in the ground. You are seeing to the this is semicircle. This is a secondary rainbow. Secondary rainbow. Rainbow. So this is a primary rainbow. Rainbow. Primary rainbow. Rainbow. This is a secondary rainbow. Primary rainbow. Actually, the sun is at this place. The sun is at this place. This is the sun. This is observer stand here. Observer at this place. Observer is at this place. Sun is behind the observer. So rainbow is in front of the observer, in front of the observer. Actually, this is a rays coming from sun. Rays. This is a light rays coming from. This is light rays coming from this light rays. This light rays are coming from sun. This is coming from sun. So this is coming from sun. This is a light ray. This light ray is also coming from sun also. This is a light ray. But this is light ray. This is a light ray and reaching to the observer and reflection. This is a rays are coming from second rainbow. Here also we are getting two rays of this light, this light. So this is color is dawn color is violet. Dawn color is violet color. Violet color. Violet color. This is violet. This is a red. This is a red. This is a violet. This is a here is from red to red color. Red color is what is the value of this one means 40, 43, 45, 45. That is range is 45 degrees. So we are checking. That is a red is we are checking 42 degrees, 42. And the violet we are checking, violet is 40 degrees. This is a red, this is a violet. So next again violet color is we are checking 55 degrees. Next red color is 53 or 52. 52 or 53 we are checking. 52 you can take. Near some books given 3, some books are given 2. This is a 52 degrees. Observe. So you are seeing this is a rainbow. You are seeing too. This is a rainbow. But shape of the rainbow, shape of the rainbow. This is shape of the So you are seeing to this is shape of the now. So this is the upside is upper part. Upper part is this is a secondary rainbow. This is a primary rainbow. Primary rainbow. Okay now. So this is a primary. You are seeing this is a primary rainbow. This is a primary. So here also you are seeing this is a rainbow is this is so this is we are seeing two secondary rainbow. This is a secondary rainbow. Secondary rainbow. Actually, practically you are seeing this one. Practically you are seeing this one. Practically. Suppose you are standing in the ground. You are standing in the ground. Rainbow. This is a natural rainbow. You are seeing natural. So when we are seeing to the natural rainbow means rainbow is produced. Rainbow is produced when it is producing dispersion of light by raindrops. The raindrops floating in the air after the rain. So rainbow is formed. So when rainbow is formed means after the rain. Rainbow is produced due to dispersion of light by raindrops. These raindrops float in the air after the rain. So after the rain, So here actually rays, this is a rays are coming from, this all rays are coming from the sun, coming from the sun. This is observer. Rainbow is from in front of the observer, but the sun is behind the observer, behind the observer. This is a observer, observer. This is a observer. This is a sun. This is a sun. This is a rainbow. This is a rainbow, right? Oh, this is a sun. This is a sun. So what you see finally, sun displays, observer displays, rainbow is formed here. Rainbow is formed here. So how does it form? How does it form? That I'm going to explain. That I'm going to explain. I'm going to explain how does rainbow form? Rainbow form. Okay. So this is how practically you are seeing. Suppose, for example, you are in the ground. You are seeing the shape of the semicircular shape. You are seeing. You are in the ground. You are seeing the rainbow semicircular shape. Suppose, for example, you are in the helicopter. You are in the airplane. You are seeing the full shape of the rainbow. You are seeing full shape of the rainbow. You are seeing full shape of the rainbow. You are seeing this is a full shape of the rainbow. You are seeing. Okay. So now I'm going to explain how does it form. How does it form? How does it form? I'm going to explain. So we have secondary rainbow, primary rainbow, primary rainbow. Is it that one primary rainbow, secondary rainbow? Now, primary rainbow, secondary rainbow. Same, primary rainbow, secondary. So we have a sequence in the primary rainbow, secondary rainbow, primary rainbow, secondary rainbow. This is secondary rainbow, secondary rainbow. Okay, Nasina? So this is a light ray. Light ray coming from, this is a light ray is coming from sun. So this light ray strikes at this point. This is a raindrop taken as a denser medium. Outside, this is the air is outside surrounding. That air taken as a rarer medium. Light travels from rarer to denser, rarer to denser. So we have to draw the here, draw the draw the perpendicular to the surface, perpendicular to the surface. This is we call normal. This is actual direction of incident ray. But this is a light ray travels from radar to denser. Refractor is bending towards a normal, towards a normal. This is one light. So I'm not seeing to the seven colors. Actually, this white light strikes top surface of the rainbow. This white light is split into seven colors. Seven colors. This is a seven colors. This is a this white light. This is a white light. This is a white light. False. This is a white light. White light strikes top surface of the rainbow. It splits into seven colors. So seven colors. This is a seven colors. I'm not showing the seven colors. I'm showing two colors. Two colors. This is one refraction. Here, light travels from brighter to denser means this is a refraction number one. Refraction number one. Number one. So after it is strike at this point, this rays takes total internal reflection number one. Total internal reflection. So takes total internal reflection means what will happen? Again, it will be it is reflected this direction. Reflected this direction. Okay, it is reflected this direction. So again, this is reflected here. So again, so this is actual direction of incident ray. Actual direction of incident ray. We have to draw perpendicular to the surface. Draw the perpendicular to the surface. Perpendicular to the surface. Again, this is light travels from denser to radar. It is away from the normal. Away from the normal. It is bending away from the normal line. Away from the normal line. Okay. Away from the normal. Actually, the ray is bending away from the normal. I'm showing. I'm showing clearly. Okay. So this is a rain. This is a raindrop. Raindrop. So this is one light. This is a this white light splits into seven colors. Seven colors. You are seeing to the this colors. This is a one, and this is a. I'm showing two colors. Remaining colors inside that. Inside that. So this is again. This is a takes a total internal reflection. Takes a total internal reflection. It is a reflector. It is a. It takes a total internal reflection. Again, it is take the reflection. It take the reflection. So once again, it is a bending. It is a it takes the total internal reflection. Take the total internal reflection. So take the total internal reflection and carefully drawing here. So it is reflected here. It is reflected here. So again, it is reflected here. Reflected here. So drawing neatly. Okay. So this is a rainbow. Water droplet. Water droplet. So it is reflected here. Strike at this point. It is reflected here. Okay, this is the actual direction of ray. So here we have to draw the normal line. Normal line. So this is the actual direction of ray. Actual direction of ray. Actually, the rays travels from denser medium to radar medium. Refractor is bending away from the normal. Away from the normal. Away from the normal. So this is a ray. Meter. So observer is at this point. Observer is at this point. This is a observer. This is a observer. Observer point. Observer point. This is a white light. White light. White light falls here. This is a white light. So here takes it. This is a total internal reflection. The light takes the total internal reflection one. Here so here also refraction number two. This is a so light ray is refracted at this point. This is a refracted one. So light ray again light ray is refracted at this second refractor in second refractor. First refractor, second refractor. Here this is a light takes a total internal reflection here. Here this is a primary rainbow. Primary rainbow. This is a observer. Observer at this place. So this is observer seeing the colors. This is a violet. This is a red. So from red is 42 degrees and violet is this is 40 degrees. 40 degrees AC. Next is secondary rainbow. Secondary rainbow. Secondary rainbow. So what will happen in this situation? So light ray, this is a light ray. So coming from, this is a light ray. This is a light ray. It's coming from, this is a light, white light, white. So white light. This is white light coming from, this white light coming from sun. This is takes the total internal. This white light strikes the raindrop. It's divided into 7 colors. It divides into 7 colors. 7 colors. This is light travels from radar to tensor, means it is towards the normal. Towards a normal. I'm showing the only two colors. Two colors. So this is color number one. I'm showing you the second color. Second color. This is at this place. White light. White light slits into 7 colors. We call that this dispersion of the light. Dispersion of light. After the dispersion of light, at this place, light is refracted at this place. Refraction number one. Refraction number one. So this is at this place. This is a light ray. Light ray strike at this point of after angle of incident ray is greater than to critical angle. After it will be what happened. So it is it take the total internal reflection. It take the total internal reflection one. Total internal reflection one. So again, it is reflected here. So once again, total internal reflection. This light is fixed as again total internal reflection number two. Number two. So this is again light is reflected here. Again, light is reflected here. You see this is angle of A is equal to angle of R. Law of reflection is also valid here. So light ray again. This is a point. This is a normal. Draw the normal to the surface of the water droplet. Water droplet. So this is the actual direction of ray. Actual direction of ray. Light travels from tensor to radar. It is bending away from the normal. Away from the normal. This is a normal line. This is a light is bending away from the normal. Means this is away from the normal. Away from the normal. You are seeing this light ray. So away from the normal. Normal. Then this is also bending away from the normal. Away from the normal. This is a observer. This is a observer. You are seeing the observer. This is a ray. Okay. This is a from here to here is we are seeing. This is a violet. This is a sorry. This is color says what is colors? Colors violet, red, and this is violet. So this is 40 degrees now. So this is color says here. This is a violet means. So this is violet means 55 degrees. Red means red means that is 52 or 53. 52 or 52 degrees. This is a 52 degrees. This is a rainbows. That is a rainbows. This is a ray directions. This is a ray directions. This is a ray directions. This is a primary rainbow, secondary rainbow, So this is a rainbow. The primary rainbow, secondary rainbow, primary rainbow, secondary rainbow. So primary rainbow, secondary rainbow in this both cases. So primary rainbow. So dispersion takes place and refraction, 2 refractions, so total internal reflection, 1 total internal reflection. Secondary rainbow, dispersion and the refraction 2 and total internal reflection is 2. Okay, you are seeing to the primary and secondary rainbow. Secondary rainbow. This is a rainbow. This is a rainbow. Now we'll see what is the meaning of dispersion. Dispersion of light. So white light falls on the plane surface of the prism that can slits into 7 colors. That is a VGR. So white light is a form of 7 colors. White light is form of 7 colors. So 7 colors. Okay. So one color having the one frequency and one color having the one wavelength. So wavelength. So red has more wavelength. So violet has less wavelength. And the red colors having the minimum deviation. Red colors have the minimum deviation. white color having the more deviation, more deviation. So now dispersion means, do you know very well? So white light is splits into so many colors. So that is a dispersion of light. Refraction means, do you know very well? Refraction means lights bends, lights bends, lights deviates from actual path on entering into the second medium. That is a refraction. Do you know very well total internal reflection? What is the meaning of total internal reflection? We have the three situations. Light should travel from denser medium to rarer medium. Denser medium to rarer medium. Inside this is a light. This is a light travels from denser. Again, it is reflected in a denser medium. This is a one. This is a light takes as a total internal reflection. Here, this is a light travels. This is a denser medium. This is a light is instant on here. It is reflected here. Light travels from denser. Again, it is reflected in a denser medium. This is a one total light takes as a one total internal reflection at this point. So next, again, light travels from denser medium. It is instant. It will reflect in a denser medium. Again, light takes as a second total internal reflection here. This is a one refraction here, second refraction. In the primary rainbow, dispersion, refraction two, a total internal reflection is one total internal reflection. One total internal reflection. TIR, total internal reflection. Here, this is a primary rainbow. This is a secondary rainbow. Secondary rainbow. You are seeing to the figures. So that is a rainbow, right? Rainbow. That is a rainbow. You are seeing to the this is a rainbow. So this topic is over. This topic is over. This topic is over. So next topic is next topic is. So I'm going to explain that is a lab activity. Lab activity. So what is a lab activity? You have seen. We're going to this. Next lab activity 2. Okay. So okay, today class is over. Tomorrow I will explain lab activity 2. Lab activity